Hi, good afternoon, folks. Welcome to the first of a series of webinars. This one is entitled Let's Talk Software-Defined Storage. Your two presenters today will be myself, Myles. I'm a solutions architect with Novosco, been working with the company 3 years, been in the IT industry for about 24 years. And with me this afternoon is Myles Gray. Myles, do you want to introduce yourself?
Sure. Hi guys, I'm Myles. I'm a cloud technologist for Novosco. I primarily focus on VMware and network technologies, and I'm responsible for the design and architecture of Novosco single-tenant cloud.
So guys, as I say, today's topic is software-defined storage. For those of you who are familiar with GoToWebinar or have used it in the past, you may know, or if you don't, at the right-hand side in your little control panel, there's a questions area. Please feel free to ask any questions throughout the webinar. If we don't answer them verbally, we will get back to you after the webinar. We also have a few polls. So this really is just to help us get an idea of who the audience are, where you are on your cloud journey, where you are on your virtualization journey. So I'm going to pop up the first of the polls, which is basically a very simple question, which is, what is your current level of server virtualization within your environment? So if we can get you to click on your answers, please. Okay, so that was interesting. So we have an even split of 33% fully virtualized, 33% partially virtualized, and 33% with no virtualization. So we're going to follow this up with a second poll, which is, bear with me 2 seconds here, guys. So the second poll is, for those of you that are virtualized, what virtualization platform are you using? So we've got the others category, Hyper-V and VMware, obviously the two market leaders in this area.
Other could also stand for public cloud in this instance if you have stuff in
Absolutely.
AWS.
Absolutely. So if it ain't VMware and it ain't Hyper-V, just click other.
Okay, a very heavy weighting one direction for this.
Yes, yeah. I suppose that's what we standardly see in industry. Most people who have gotten into this market sector have gone in with VMware. There's a few in the market sector that are moving away from VMware towards Hyper-V and towards cloud providers, but it's pretty heavily VMware biased at the minute. And then we have one final one, which is for those of you who have started, cloud adoption. So have you done any cloud adoption? Are you Office 365 users, that sort of thing? Are you just in the process of discussing cloud adoption or even debating it following the recent AWS outage? Or are you really just not even talking about it at this stage? Okay. So no one's really not done anything. You're either discussing it or already started. So that's an interesting. So what we'll do is that just gives us a little bit of background, helps me and Myles understand where you are in your journey and how we can tailor what we're going to talk about today. So as I say, we're talking about software-defined storage. Myles, if you'd like to bring up the agenda there.
Here we go.
So we're really going to try and help you understand what software-defined storage is about, why software-defined storage is of benefit to organizations or why people are even considering it, look at the workloads, business types, and scenarios where people or organizations benefit from software-defined storage. And then we're going to spend a little bit of time focusing on, quite aptly considering 100% of you are using it, VMware's software-defined storage offering, which is a product set called VMware vSAN. We'll look at what it offers as a product, what editions it's available in, and really try and report back what we've seen through the vSAN implementations we've done with clients and the stuff we've done internally, the gotchas, the things you have to consider. Yeah, as with everything, software-defined makes it sound really nice and easy, and it makes it less complex, but it isn't easy. So there are some gotchas you need to look out for. Finally, we'll wrap up by looking at something called the Novosco single-tenant cloud, which is our private cloud solution that is based around software-defined storage.
Alrighty, let's get into it then.
Cheers, Myles. Right, so software-defined storage. There is no true definition. It's a marketing term, let's be honest. But what it really stands for is the process of trying to abstract from a typical storage controller, so that's your old-fashioned array controllers, functions that would have been built into the hard-coded software and ASICs, the dedicated hardware of those controllers, into software-defined, into software-only layer. And that would allow it to be disaggregated from specialist hardware. It would allow organizations to span those services onto what we would akin to more commodity hardware, so JBOD type solutions, just a bunch of disks, Intel servers, and more worryingly, it allows you to build it yourself. And I say more worryingly, you'll see that there's a recurring theme as we talk today around how most early software-defined storage implementations and most forays into it, and I'm going back here to the early 2000s, failed because people weren't getting the underlying hardware. So we've heard about software-defined storage for the last 24, 18 months. We've heard a lot more about it, but the truth is it's been around for a while. So that's the basis of it. But Myles, there's also some other stuff that's been added into it recently, isn't there?
That's right. I mean, because there's this abstraction away from the hardware, you don't have dedicated silos of performance or redundancy anymore. So typically in your hardware-based arrays, you would have maybe a flash tier, a SAS tier, an airline SAS tier. You don't really have that with an SDS solution. Your service levels and redundancy are defined at, excuse me, at a policy level in software. So what that means is you can have VMs that exist on the same SDS solution that have completely different characteristics with regard to performance or redundancy. Some might be highly redundant, whereas others, test and dev ones, can be tagged differently and be less redundant. But there's no need to actually silo stuff up and put it into different sort of pots of performance or redundancy like you would with a traditional array.
Okay, so if we can move on to the next slide, Myles. Okay, so the whole reason why people look at software-defined storage is that they've realized that there are challenges with the historic approach to doing storage for large virtualization platforms. Historically, we've had this whole three-tier storage area network, compute, and array controllers looking after disks, and that was specialized and expensive hardware. It was a one-off investment. It was, in most cases, an opportunity for vendors to tie you in because they sold you this lovely big array, and then all you would do is keep adding more and more disks to that array. But people start to realize technology was moving a lot faster. By the time you got 2 or 3 years into your previous array, and that array might have been scaled to have 5 years of growth in it, yeah, you realized, A, I've not used all of the stuff I've been paying for because I haven't scaled yet, and B, technology has moved on so much that the software feature sets that I have in this 3-year-old array are now outpaced by what people are doing in the newer arrays. So you ended up with low utilization, over provisioning, that sort of problem.
Yeah, and that sort of leads into, because the hardware was specialized, you bought an array with specific data services on it. So say an array, you needed encryption at rest, or you needed compression or deduplication. These were features of that particular make and model of an array that couldn't get moved on. You had to buy the next controller, or you had to move one model up, or however it worked. Whereas with an SDS solution, because it is software defined, you have a standardized hardware build that you use across the board, and then depending on what the software supports and what upgrades you do to the system, that dictates your feature set essentially. So if you want compression and deduplication, you can add that in if you upgrade your software to a particular version, or if the vendor keeps innovating, then your licensing that you're paying to them every year gets more value than it typically would with an EMC one, where it's money that you put into a piece of hardware that doesn't get any extra features, whereas with a software-defined solution, it continually evolves.
And there was in the old three-tier model, there was complexity. If someone wanted to add a new VM, they first of all had to ask someone in the storage administration team, which data store should I put a VM on? And it wasn't that simple all the time. The data stores, and I can tell you many a story from people who've looked at the data store and gone, well, that data store has got gigabytes, even terabytes of free space, and they've started to push VMs onto what they believe to be free space, forgetting that those data stores were sized for performance and not necessarily for data consumption. So behind, and I remember one client in the north of England who had 25 terabytes of free space, but actually it was only sitting on 6 nearline SAS drives. So as soon as they started to think, oh, we can use this free space without actually investigating the back end and without talking to storage administrators, the VMs that were running on there just ran very poorly. So there's this complexity process that's always had this storage administrator at the center, almost like the guru saying who can have what and when they can have it.
Sure, and that results from the typical static class as a service that you would have. You have a tray of Flash, a tray of NLSAS, or whatever it is, and those are your pots of performance. And there's no real mixing or matching between those. You either get everything's really fast because it's on Flash, or everything's sort of okay because it's on NLSAS. You can't really be deterministic about where you place your VMs without a lot of operational overhead.
Okay, so why did software-defined storage came about? Well, mainly it came around because it gives flexibility for the construction of services on top of commodity hardware. Software-defined storage allows us to span the boundary between servers and storage. It allows us to actually use more tool sets to take either whether it be static tagging or labeling of, for example, VMs or the VM storage, or automatic tagging and labeling of the VM based on some form of automation, and relate that to the way that the storage works for us. It means that data services can now be more application-centric rather than server or even storage-centric. But we also have to bear in mind that it does impact the potential security or reliability levels. It is absolutely brilliant that you can go to manufacturers like EMC, NetApp, Hitachi, whoever, and buy a SAN that is going to have their stated 5 nines uptime. As soon as you buy a piece of software and start building the hardware yourself and constructing the data plane yourself, then the 5.9 responsibility lies solely with you as the end consumer of that product.
Sure, and it's important to note that there's a lot of solutions out there that have done data path virtualization. What we mean by data path virtualization is you would have your array controller, and then you would have your SAS trays underneath it, and they were all connected to each other by 6 gig SAS cables. In an SDS solution, or there's quite a lot of solutions out there actually that just use Ethernet as a transport between their disks and their controllers, or if the controllers are hyper-converged, then it uses Ethernet for everything. And the fact that it uses a converged data plane and control plane doesn't necessarily mean it's SDS. SDS has more to do with, at least in current day terms, a scale-out sort of architecture that whenever you want to add more storage or more compute, you add a node and it scales out linearly, performance-wise, and everything else.
So that is a valid point. That just before we move on, Myles has touched on something quite interesting there. SDS, we see a lot of SDS services based inside hyperconverged. Hyperconverged really does rely on SDS, but SDS doesn't rely on hyperconverged. You do have manufacturers, well, let's be honest, Datacore back in the early noughties were doing software-defined storage where you could buy commodity hardware and run their software. They struggled a little bit because they didn't have a standardized hardware offering. I think the first manufacturer we really seen blossom in this area was NetApp. No matter what NetApp controller you bought, the software was the same. It had the same capabilities. The truth was that you'd simply buy their controller based on the power you need. The reason they succeeded is because they kept you to a stringent set of hardware. They controlled the hardware rather than giving you a hardware compatibility list and saying build it yourself. But Myles picked up accurately that software-defined means a lot more now. Software-defined means the ability not just to control all the services with software, but to automate, to manage, to react.
Sure, sure.
So one of the things that we find when we put something in software, its boundaries become less limited, yeah? You know, the idea that we're doing something in software means that by simply changing the software, by evolving the software, we can then start to include other stuff. We can start to include automation. And indeed, we can start to even span out to cloud services, whether that be your AWS's, your Google's, or your Azure services. We will, bandwidth permitting, would you agree, Myles?
Yeah, it's absolutely bandwidth permitting.
In the next few years, find people, well, EMC already offer VSAs and software-defined storage solutions that span out to their own EMC clouds. They were early days referred to them as data lakes, yeah? But I think the biggest holdback on this within Europe at the minute, or at least within the UK and Ireland, is bandwidth availability to get into the clouds for data to move between hybrid cloud environments and public cloud environments.
Sure. Okay. Yeah, so SDS, it works with scale-up or scale-out architectures. By scale-up, what we mean is a more traditional sort of view on things. You would have your controller, and you have some trays attached to it, and that is a scale-up. You add more and more disks to it. And you gain more capacity as you scale out that way. It can also be software defined. You know, they can replicate to each other, or there might be data services that are virtualized on top of those things. But typically what we're seeing now is more of a scale out type architecture, and scale out means horizontally rather than vertically. So instead of adding a big controller and then a tray of disk and another tray of disk, what you do is you add a node with a fixed specification, and then another node with the same spec and another node, and they scale all aspects of the architecture out as they grow. So you're adding compute and storage at the same time with each one, which is quite the departure from the old way of doing things. If you had a hardware array, say a VNX 5600, you bought that because it had enough grunt to look after all the disks behind it and provide the data services on top of it. With a scale-out architecture like vSAN, what happens is, because you're scaling out the compute with the storage, you also scale out the capability to provide data services. So as you add more nodes, you're not necessarily needing a more powerful controller, because your controller is these nodes themselves, so they scale out nicely with that.
Yeah, and I suppose the whole idea of moving all of this into software-defined layer is the idea that we're going to remove, in future, forklift upgrades, the point where, as Myles said, you finally find that you reach the physical limitation of an EMC 5600 and have to move to 5800, and suddenly you've got a whole pile of work to do. It is also worth knowing that there are two factors in here. Number one, all of the manufacturers are trying to make it possible to include historic investments in their new solutions. So this is the idea where you already have or might have an investment in a scale-up architecture, and you now want to bolt on scale out to that and continue that as your way forward. And the second thing is some of the hyper-converged vendors, people like Nutanix, people like Cisco with HyperFlex, Maxed Simplicity have just been bought by HP. These guys are all starting to realize that in some cases the scale out doesn't work linearly. So they're starting to look at building into their software-defined storage and their scale-out capability, the idea of adding a storage-only node rather than a storage and compute node.
Sure.
So Software-defined storage real value is that it enables the disaggregation, lovely word, of storage as data services. So the idea here is that we are basically saying, irrespective of the storage platform I'm using, the data services, because they are defined and delivered by the software on top of that storage platform and not tied to the hardware, allow us to do a lot more work. They allow us to do a lot more flexibility. They allow us to do a lot more scalability. But that's only half of what software-defined means these days. The other half, as Myles has said, is self-service.
Yeah. And the policy-based management. I mean, the ability for the administrator to create set availability levels or performance levels and create those labels in, say, vSphere, and have a developer or a junior admin or someone go in, create a new VM, and all they do is apply a tag, and it goes and creates the storage with that availability and performance profile for them is very powerful, because at the start you're defining what your expected performance and availability options are. So as an application changes through its life cycle, as it goes from test and dev to, POC to production, you can change those performance and availability levels by just simply retagging a VM, and the software-defined storage solution will just go out and change where it lives on disk, how many disks it's replicated across, and all the other back-end stuff for you without any specialist storage knowledge from the user that's actually enacting the change.
So what I want to do now is talk about VMware. VMware specific, it seems that most of our audience today are using VMware as a hypervisor. So VMware, a couple of years ago now, brought out a product called vSAN. And VMware really have two sides to their software-defined storage. Most people think of vSAN as their software-defined storage solution. And yes, that is the bit that enables the hyper-converged architecture, enables the commodity hardware to come in. But sitting on top of that with the vSphere policy and management engine, they have app-centric storage automation. So even if you don't have vSAN sitting below, and why wouldn't you? But if you don't, you can still use some of the storage and policy automation. You just can't tune it as much as you could if you have an old historic 3-tier array solution. Yeah.
Sure.
vSAN comes in 5 editions. In truth, there's 3 main editions, and then there's a second version of 2 of the editions, which I'll let Myles talk about at the end. But they're basically a standard, advanced, and enterprise. Now, its edition does not need to match your ESX edition. So if you're running vSphere Enterprise Plus, you might just go for vSAN standard with that. You can mix and match these values, but one of the big changes that's just happened, this grid sheet we're showing you now, is for the latest edition of vSAN 6.5. And with 6.5, one of the major changes was that the all-flash capability was added to the standard edition. Previous to that, you had to purchase advanced or enterprise to get all-flash. Now you can do it with the standard edition. And this is another thing worth noting. What we're seeing now with the advent of more people going all-flash and the abundance of IOPS that all-flash has given, we're now seeing less and less people having to worry about have I got the performance, yeah? Maybe they're still worrying about have I got the capacity, but they're not worrying so much about have I got the performance. And this is where we're seeing some of the old-style storage vendors knocking back at software-defined, saying, well, why do you need to tag things into different pools if everything just performs for you? So that's where we're seeing the likes of your Violins, Tintrees, and Pures coming out with their all-flash solutions.
Sure. And then there's the Robo solutions, which are quite interesting. They have a very particular use case. So Robo comes in 25 VM packs. Basically, they're meant for remote office, branch office sites. So if you need to have your workloads close to where they're being used, then Robo is a very nice solution for that. It allows you to run 2 nodes of ESXi with vSAN on top. You can directly attach them to each other with 10 gig cables. You don't need to buy any expensive 10 gig switching. And you can just put in these 2 pizza box servers, rack them up, and then connect them back to your main data center where you run a witness. And that's the entire infrastructure for that location set up. So we see this quite a lot in retail settings. What typically happens is we'll have a main data center somewhere, and then all the retail outlets will have a robo cluster in them, a 2-node cluster, and then that talks back to the main data center just to maintain quorum so that there's a, break that can decide who wins. But Robo is a very good point solution for small remote offices that don't maybe have a lot of infrastructure for power or cooling or anything like that, just because of the small footprint that you can put something like that into.
Yeah, and it is worth noting, as Myles sort of mentioned earlier on, the Robo is 2-node deployment. It's a maximum of 25 running VMs, and it's licensed per VM. Unlike the standard advanced and enterprise, which are licensed based in this, well, the same way as ESX or vSphere is licensed, the physical CPU sockets that are in the environment. So let's talk a little bit. We entitled this vSAN gotchas from the coalface. Let's be honest, Myles, it's probably more gotchas in general with any software-defined storage, or at least any software-defined storage where you choose the hardware. Is that a fair comment?
Absolutely, yeah. I mean, any software-defined storage solution can't escape the realms of physics. Either something can provide the throughput or it can't, and that's one thing that needs to be made acutely aware is whenever you move to a software-defined storage solution, you go from a model where the array vendor, HP, EMC, Hitachi, whoever it is, are your one point of support for everything. So they supply the hardware, the software, and everything like that too. Now you buy these nodes. You can buy vSAN ready nodes, of course, which come from vendors like the above. And what will happen is they can support the hardware for you. But if you build your own, you need to be aware of what components are on the hardware compatibility list and the drivers and firmwares for them. So one thing that was an early gotcha in the early vSAN days was there was RAID controllers on the HCL that, yeah, they were qualified and they worked, but maybe they weren't necessarily performant enough for the use cases people expected to use them for. So it is important to understand your workloads and to go through the HCL and spec things out accordingly based on what you expect your throughput and IOPS to be. But the RAID controller is probably the single most important thing that you decide on whenever you design a vSAN solution.
Yeah, let's be honest, if you don't get the RAID controller right, it's like turning up to Le Mans in a Prius.
Yeah, pretty much. Yeah, you can have all the disk that you want, but it won't go anywhere. The drivers and firmwares are very important as well. That's at a RAID controller level, BIOS level, disks. Now, all this information is provided by VMware on their hardware compatibility list. So if you want to go out and build a solution like this, you can do that. You can pick the components off the HCL and ensure that they have the hardware or the firmware and software and driver versions that are specified there. But the important thing to realize is that is now in the customer's domain.
Yeah, so you've taken responsibility as a customer for the 5 nines.
Yeah, exactly. Which is exactly what Myles said earlier on. You don't have the single point of contact, and you don't have that guarantee of this SLA. You sort of define the SLA yourself. So there's another thing to be aware of is whenever you use a hyper-converged SDS solution, not necessarily every SDS solution, but a hyper-converged one where your compute platform is also your storage platform, like vSAN. If you have some data services that are released in vSAN 6.5, for example, the iSCSI target service, if you want to use that in your environment, you also need to upgrade your ESXi version because they are intrinsically linked to each other. vSAN runs in the ESXi kernel because it's very low level, there's very low overhead there. It makes sense to run an SDS solution at that kind of level, but what it does is intrinsically link your storage solution to your compute solution. So that is an upgrade of the entire platform all at once. They're not able to be done separately like they would have been in the past.
Myles, would just before we move on, would it also be true to say that for the full capabilities to be visible down to the application and the OS, one of the things you do have to make sure is that you keep your VM hardware up to date as well.
Yeah,
Yeah, I've walked into numerous VMware environments that have gone through upgrades where we're still using version 5 of the VMware hardware, even though we should be up at version 8 or 9.
Yeah, that's right. And those VM hardware versions do expose new features through to the application and the OS. So it is very important to keep those up to date as well. But that is good practice just across any environment. It's not necessarily SDS specific. So this sort of is related to what we talked about earlier with the RAID cards and firmwares and drivers. But once you've decided upon your POC environment, say, you build out your environment with the firmware and driver versions and the hardware that you intend to run in production, and it is absolutely imperative that you load test it properly. You give it proper production workloads, not necessarily synthetic ones, but they do work as well. But more of like what you would expect to see in a traditional working environment. So, move some of your workloads over, clone them or something, and then what you can do is run those as if they would run during the day, and then run backups on them, and just stress it as if it was a normal solution. If you have a DR solution, integrate it with that as well to make sure that it works exactly as you expect. Because the important thing to remember is with vSAN, I mean, now it's typically all flash, how you build it, because you've got your compression, deduplication, erasure coding that lets you take advantage of specific hardware, software features that mean you get more capacity out of your disks. But in a hybrid solution where you do some SSD and some SAS drives, so that it destages onto the SAS drives whenever it's not hot blocks, typically just, like how you would have a auto tiering in a VNX array. What can happen is if you don't adequately size your SSD tier and you're doing an awful lot of work, what's going to happen is you'll fill up your SSD tier because it can't destage to the back-end disks quickly enough. And then what happens is your SSD tier slows down to the same speed as the spin and rust behind it. So it's just it's a performance impact, but it is important to properly load test an environment like this because, again, there are no guaranteed SLAs.
And again, a good rule of thumb, it's a rule of thumb that you've probably heard time and time again, is that when you're dealing with ESX hosts and virtualization hosts, you really want to get the best out of them, but save yourself the problem of them getting too hot. Run them around about 80% CPU. When you start to use software-defined storage and stuff like vSAN, which is processing at the hypervisor level, or any other software-defined that's processing at the hypervisor or VM level, you really want to tune that 80% back to around about maybe maximum 60-65%, so you're giving the overhead there. And also think about what happens in the event of problems. So if a node were to die and you're using failure to tolerate levels, which Myles is just about to come on to, how long is the rebuild going to take? How long will it then take to rebuild onto the node when you replace the node? And also, bear in mind that the raw storage is now what you are seeing at the VM level. So, Myles, I'll hand back to you because you've got this covered.
Sure. So, traditional array sizing is quite easy, to be honest. You look at your current working set, you add 10 to 15% year-on-year compounded, and then you get what you should arrive at the end of your 3 to 5 year term on your array, and then you maybe add 10% onto that for uncertainty. So at the start of your array buying cycle, you'll define what you need at the end, so you buy it all up front. There's your raw capacity, you split it up into RAID groups and pools, and you provision your VMs, and it's fairly static. With an SDS solution, because it is policy-based, you can say you have 3 nodes in a cluster. Each one has 10 terabytes of raw storage in them, so you have 30 terabytes of raw storage. That doesn't necessarily mean you have 30 terabytes, of usable storage. So it depends on what policies you apply to it. So vSAN has this concept of failures to tolerate. So you have FTT equals 1, 2, or 3. So that means it can tolerate 1 failure, 2 failure, or 3 failures based on your cluster size. If you want to tolerate a RAID card failure or a host failure or whatever it is. So as you change VM's policies, say you move, say you have a 100 gig VM that has an FTT equals 1 because it's in test and dev, so you want it to tolerate one failure. So that 100 gig becomes 200 gig because it needs to keep it in two places. It's like RAID 1 on a traditional array. Now, you move that into production, you want it to be a little bit more redundant, so you would set it to false tolerate equals 2, or you'd have a policy that's called production that implies these settings. And what it'll do is it'll grow that from 200 gigs to 300 gigs because it needs to keep the data in 3 places. So depending on where you see your VM sitting and how the policies are changed throughout the life cycle of a solution, the amount of available space is going to vary quite a lot more than it would on a traditional array.
And it is worth noting that a lot of people, when they look at this and then they think about the rebuild time and the fact that errors can happen during that rebuild time, I think most people I've spoken to, most blogs I've read have said that they default to failure to tolerate 2 in most vSAN or software-defined deployments. That in itself brings in its own interesting concepts in that to do a failure to tolerate 2, Myles, what's the minimum number of nodes that you need?
You need 5. So it's like RAID.
Nodes.
So say you have a RAID 5 pool and you have a disk fail. Everyone knows RAID 5 can survive 1 disk failure, so that's not a big deal. And you swap the disk out, you put the new one in, and your data starts rebuilding onto the 3rd disk again. But then one of your other disks has a failure. That happens in RAID 5, but it also happens in software-defined storage land. If you have a node failure, say you have 3 nodes, it's essentially RAID 5. You take a node out because it's failed, you put a new one in, starts rebuilding, and if you have a failure during the rebuild time, it's going to result in an outage. So this is why we get this failure to tolerate 2 is typically the way to go. So you have the size for 5 nodes, you can tolerate a failure during a rebuild.
So again, the interesting point there is that, you know, if you are a small organization, you might actually be sitting there thinking, oh, vSAN sounds brilliant to me because I only really need 2 or 3 hosts worth of compute, and if I can stick my storage into those hosts and use vSAN, fine. But then you're really limiting yourselves to your failure to tolerate capabilities.
That's right. Al talked about earlier as well, and I touched on as well, which is the virtualization of the data path. Essentially just means that your data is now transferring over Ethernet. It's being replicated over Ethernet from disk to disk, or parity is being done over Ethernet as well. So that means you need to have a mature network. You know, if you were using 6 gig SAS from your controller to your disk trays in the past, you're going to need 6 gig again. Well, it doesn't exist in Ethernet land, so you need 10 gig networking to provide the same sort of level of performance. And it is very, very important to get the design and architecture of the network right before you embark upon building out a production environment for an SDLC.
So guys, software defined is good, but as with anything, it has its own gotchas, it has its own clawbacks. So maybe what we should do now, we're going to try and wrap up in the next couple of minutes, but to do that, we thought we'd show you what we've learned from the coalface. Your best teacher is your last mistake, and yeah, we've made mistakes along the way in our test environments and so forth, but what we've now put together is this offering we bring to market called single tenant cloud. So the idea of single tenant cloud, well, Myles, you know, it's your baby, so I'll let you give some of the background here.
Yeah, sure. So we looked at how service providers traditionally implement a solution for multi-tenancy, and generally the way enterprises tend to go is they'll either buy colo or they'll go with infrastructure as a service. So in colo, you buy a rack in the data center, you buy some top rack switching, some routers, some compute, storage, physical appliances, back channel. You're responsible for how much U is used in the rack, how much power is being used. Hardware failures, you have to enact the vendor to go out and change those for you. You know, you have to look after sizing and all that kind of stuff. And then the only other alternative that there really was IaaS, which was you have a virtual data center provided by a third party, and there's VMs that you just run on top of it. And that was it. There's not a lot of flexibility, so you get to run VMs, but you can't really do much else. So with STC, what we wanted to do was make a hybrid of these two. So typically, the way we explain STC is it's a mixture of Colo and IaaS. So what we do is we provide you with a virtual data center. You can put your VMs on it. It's the same console that your IT admins will be used to on premises. It's vSphere, so if they can manage it on premises, they can manage it in STC. You can bring your own current investments in licensing. So if you already have an agreement with VMware for 8 CPUs of licensing for that, you can bring that in. We can use that in STC. You don't need to buy discrete licensing. You can bring your own DR solution or service from yourselves or a third-party provider. And you can bring your own backups as well. That includes your own backup software. We do have some recommendations around it, but within reason, you can bring your own backup software. The main selling feature, I believe anyway, of STC is the fact that if you have physical appliances that you've got a lot of investment in, say you have some hardware firewalls or load balancers or some sort of bespoke piece of hardware, say you have a data domain, for example, that you want to ship your backups to because it's deduplicating and it'll do encryption and all the rest of it, and you want to leverage that and not have to pay for a service somewhere, we'll ask you how many U it is, and then we'll take the array, we'll put it into STC, and we'll link it into your virtual data center, and it's available for you to use as if it was in colo or if it was on premises. And you also have full control over the virtual infrastructure, so you're able to define what your pools of nightly backups are, which ones are being DR protected, the different SLA levels, and you can choose to ship data in and offsite or to your physical appliances as well.
So we're really trying to deliver the benefits of a software-defined data center, and this is a topic we'll expand on in later parts of the Let's Talk series. You know, keep your eyes open. We'll be doing software-defined networking, software-defined data center, and so forth. But what we're trying to do here is take the knowledge that we have of building a platform that truly will support software-defined data centers, put a SLA around it, i.e. we're owning the 5 nines, guys, and give you the capability to migrate into that but protect existing investment, whether that be licensing or hardware, as Myles has already covered. Thanks for that, Myles.
No problem.
So, guys, that's it. It's the first of our Let's Talk series. Hopefully we'll see some of you back on later ones. If you do need to get in contact, there are my contact details. I'm mal.toner@novosco.com or on Twitter as malconfigured. Myles is on there as Myles Gray or Blah Cloud, and the generic Novosco account is @Novosco. Thank you for your attendance. I don't see any questions in the questions box, but hey, my email is addressed there if anybody's got any questions or if anybody wants a follow-up. I do realize this is a very high-level Let's Talk session today. As you can tell, both myself and Myles enjoy getting our geek on. So if anybody wants to get more technical and talk about the designs of software-defined or how to implement software-defined in a mixed, heterogeneous environment, more than happy to have those chats.
And we do have a webinar next month on ransomware as well, and tactics to avoid and deal with ransomware too. So that's worth looking out for as well.
And that was the plug. Thank you, Myles.
All right, no problem. Guys. Thanks, guys.